In this video, we're going to develop the derivatives of inverse trig functions. But to start, I wanted to jog your trig memory and ask you to find the tangent of the sine inverse of 3/5. So thinking back and digging through our trig knowledge, what does this mean? So we always got to work our way from the inside out. So what does sine inverse of 3/5 mean? So that means there's an angle theta. So find the angle theta such that sine of theta is essentially equal to 3/5, right? That's what that means. Notice that now if you try to solve for theta, you have to apply sine inverse to both sides. So that's what this means. So draw a triangle. This isn't a value like if it was 1/2 or root 3/2 or 1, we could find the reference angle pretty quickly. But here, so we will draw a triangle. We want to find tangent of this same angle. So I'm going to place the angle here. I know the sine is opposite over hypotenuse, right? So if I place my theta here, my opposite side is 3 and the hypotenuse is 5. If you place theta somewhere else, like if you placed it up here, now the opposite will be here. So just be really mindful of where you place your theta when you draw a triangle. And so now complete the triangle using Pythagorean theorem. So call that B. So I know that a squared plus b squared equals c squared. So 3 squared, so 9 plus b squared equals 25. Subtract 9 from both sides, so you'll get 16. So b is 4, the square root of 16. And so now I have that is equal to 4. And I can finish the problem. So therefore, tangent of theta, right, because this is the angle theta, will be, what is tangent? Tangent is opposite over adjacent. So this will be opposite, which is 3 over 4. So that means that the tangent of sine inverse of 3/5 is 3/4. And so hopefully this jogs your memory a little bit about finding these sorts of things. We do need it for finding the derivative of our inverse functions. So let's start with sine inverse. So let's let y equals sine inverse of x. And what I want to do is I want to find y prime. Now, again, pretend we've never seen this before, and some of us may have never seen this before, and I want to find the derivative of sine inverse, right? The inverse function of sine. So normally when we don't know what something is, we, again, as we did with logarithms, we rely on the definition. So y prime will be the limit as h goes to 0 of f of x plus h. So in this case, sine inverse of x plus h minus sine inverse of x, right? F of x plus h minus f of x all over h. But just as we did with logarithms, we run into the problem that we cannot expand this or simplify. We can't expand or simplify, so we're kind of stuck. So similarly to what we did with logarithms, we are going to bring in implicit differentiation here. So I'm going to find the derivative implicitly. So going back to y equals sine inverse of x, what does this mean? This means that sine of y is equal to x. Does that make sense? So think about what this means. Sine inverse of x equals y. Essentially, one way you can think of it is take sine of both sides, right? So then you have sine of y equals sine of sine inverse, and those will cancel, giving you just x. Of course, that's assuming that everything is in the correct domain and everything, but we'll do it informally. So, but this really means that y is the angle whose sine is x. So using the definition of inverses. And so now we're going to take the derivative implicitly. So take the derivative of y with respect to x implicitly. meaning we know that y is a function of x, but now the way I've written it here is looking like it's not, but we do know that y is implicitly a function of x. So let's take the derivative. So derivative of sine of stuff using our chain rule. So the derivative of sine is cosine, so I'm going to have cosine of y times by chain rule y prime, because I'm taking the derivative implicitly. So this is chain rule. And this is equal to the derivative of x with respect to x is just 1. And solve for y prime. So I'm going to have y prime is equal to 1 over cosine of y. By 1 over cosine, we know it as secant. But now I have a problem, right? Because I started, how did I start? I started with y equals sine inverse of x. And so I'm trying to say y prime equals something with an x in it. So I can't have y prime equals secant of y. So let's do what we did in the first memory problem that I gave you. So draw a triangle. Hopefully that problem helped jog your memory as to what we're going to do here. So draw a triangle, and we're going to do this. So we have our triangle and we're trying to figure out what's going to go in here. Now remember, we said that y equals sine inverse x means that sine of y equals x. So that's what we are going to use here, that the sine of y is equal to x, and we're going to draw our triangle based on that. So let me write that over here. We know the sine of y equals x. So that's what we started with. So that means that y is the angle. So we're going to put y as the angle, kind of like we did with the theta. And sine is opposite over hypotenuse. So write that as x over 1. So sine of y will be opposite. So that's x over hypotenuse, which is 1. And I'm trying to find secant. I'm trying to write this as in terms of x. Secant is 1 over cosine. Cosine is adjacent over hypotenuse. So that means that secant is hypotenuse over adjacent. And so we need to find the adjacent. So again, call this b and do Pythagorean theorem. So x squared plus b squared equals 1 squared. So b squared is 1 minus x squared. And so b is the square root of 1 minus x squared. And so now I can say, okay, so going back to my derivative, then y prime is hypotenuse over adjacent. So 1 over the b, but we just found the b. So I can say y prime is 1 over the square root of 1 minus x squared. And therefore, that's what my y prime is. So now we know that for y equal inverse sine of x. Now another way that we can write that is arc sine of x. That's another way to write our inverse trig functions. Then y prime is 1 over the square root of 1 minus x squared. So what I would like you to do is try it on your own for cosine inverse. For y equals inverse cosine of x. So and another name for this is arc cosine. And so you'll see what the derivative of that is. Now we'll do it together again for what about the derivative of arctangent. So let's find y prime for y equals inverse tangent of x, right? Also known as y equals arctan of x. So you may see this arc notation because, and this is to avoid the misconception that oftentimes people want to say tangent inverse of x is 1 over tangent, right? We're used to seeing that the minus 1 means 1 over, but this is not the case here, right? This is an inverse function. So 1 over tangent is actually cotangent. The reciprocal of tangent x is cotangent x. So in order to avoid that misconception that when you see a minus 1 that means 1 over, we oftentimes use the arc notation, arc tangent, arc sine, arc cosine, to avoid people thinking that this is the reciprocal. Okay? All right, so let's try the derivative of tangent inverse of x. So we're going to do the same thing. So what does this mean? Y equals inverse tangent of x means that tangent of y equals x. And so from here you could draw your triangle right away to see what that's going to look like, but we'll come back to that. Let's implicitly take the derivative. So implicitly find y prime. So what I'm going to do is take the derivative of both sides with respect to x. So the derivative of tangent is secant square. So I'm going to have secant square of stuff y times, by chain rule, the derivative of the stuff times y prime equals the derivative of x with respect to x is just 1. And solve for y prime. So y prime is going to be 1 over secant square of y. But 1 over secant is really cosine, right? So then this is really cosine square of y. So my goal is, I should have y prime in terms of x. So that's when we go back and draw the triangle with what I know, that tangent of y equals x. So I know that tangent of y equals x, so place our y or angle there. And what do we know about tangent? Tangent is opposite over adjacent, right? So that means that this is going to be x and the adjacent is going to be 1. And I'm looking for cosine. Cosine is adjacent over hypotenuse. So we need the hypotenuse, but the hypotenuse is a squared plus b squared square root. So this is 1 plus x squared square root. So putting it all together, therefore y prime is cosine of y squared, right? Cosine square means the trig function is the one that's being squared, and cosine is adjacent over hypotenuse. So let's look at the adjacent as 1, and the hypotenuse is the square root of 1 plus x squared. So my y prime is 1 over the square root of 1 plus x squared square. So that square is going to cancel off that square root. So I'm going to have just 1 over 1 plus x squared. And so now I'm done. So what this means is therefore that if y is equal to the inverse tangent of x, then y prime is 1 over 1 plus x squared. So these are some derivatives to add to our note cards, whatever you're using to memorize the derivatives. So let me again summarize some derivatives. I'll do my trig and then we'll do the inverse trig. So we know that for sine x, the derivative is cosine x. For cosine, the derivative is negative sine. For tangent, the derivative is secant square, and so on, right? I can do cosecant is negative cosecant cotangent. Secant is positive secant tangent. And which one am I missing? I'm missing cotangent. So cotangent is negative cosecant square x. So now for inverse trig, so if I have f and f prime, now I know that inverse sine of x, the derivative is 1 over the square root of 1 minus x squared. So I'll have my minus x squared here. I asked you to find cosine inverse of x on your own. And we have tangent inverse is 1 over 1 plus x squared. And so then we'll do the other ones. So I'll just give you the other ones. So what are my other ones? So I'm going to have cosecant inverse of x, secant inverse of x, and cotangent inverse of x. If we do the same thing that we did earlier for that what we did for sine inverse and tangent inverse, you'll find the other ones. So for cosecant inverse, the derivative is negative 1 over x times the square root of x squared minus 1. For secant inverse, it is the same thing but positive 1 over x, the square root of x squared minus 1. And then for cotangent inverse is actually the same as tangent inverse but negative. So negative 1 over 1 plus x squared. So notice that our cos are still negative. So that rule still remains even for inverse trig functions. So I want you to, on your own, find cosine inverse of x and then fill in the table. Now, how do we do them? How do we find derivatives with this incorporated in them? Let's try this tangent line example. Find an equation of the line tangent to the graph of x squared times tangent inverse of x at x equals 1. So finding the equation of a tangent line, so we should by now be pretty good about those. I seem to be asking them quite a bit. So find an equation of the line tangent to a curve means you want to be able to use your point slope form and put in the point. So x equals 1, so find the y value and we need to find the slope. So what is y? When x is 1, it will be plug in 1 in there. So f of 1 is 1 squared, which is 1, times inverse tangent of 1. So what angle gives you a tangent of 1? And that will be pi over 4, 45 degrees. So now I know the point x1, y1 is x is 1, y is pi over 4. And so we need the slope. M is the derivative evaluated at x equals 1. Or we might need the full point if we have to do it implicitly, but this is explicitly a function of x, so we don't need implicit differentiation here. So M is going to be f prime of x, so let's find the derivative. So x squared times inverse tangent, so that means I need a product rule. So the derivative of this will be using the product rule. Because I have x squared times inverse tangent. So f prime then is, product rule says, is the derivative of the first, so 2x times the second left alone, plus the first left alone times the derivative of the second. The derivative of inverse tangent is 1 over x squared plus 1. We just learned that one. And so, can we simplify this? 2x inverse tangent of x plus, there's not much we can do there except write the numerator on with the 1. So x squared times 1 is just x squared over x squared plus 1. Be careful not to say you can cancel those, right? You cannot. And so evaluate it at x equals 1. So the slope is f prime of 1. So plug it in. So 2 times 1 is 2. Inverse tangent of 1. We already saw that that's pi over 4 plus 1 squared over 1 squared plus 1. So what is this? So I'm going to have 2 times pi over 4 plus 1 over 2. So what's that? Pi over 2. The 2 and the 4 cancel or reduce to give you 2 on the bottom plus 1/2. So our slope is pi plus 1 over 2. And so now we can put the equation of the line, so the tangent line, will be y minus y1, which was pi over 4, equals m, which we just found it to be pi plus 1 over 2, times x minus x1, which was 1. And you already did all the hard work in finding the slope, so if you leave your answer like this on a quiz or a test, it will be perfectly acceptable. Now on your homework, you may need to change it to y equals mx plus b. So this will just be, oh boy, how do we do that? So pi plus 1, so distribute that in there. So pi plus 1 over 2x minus pi plus 1 over 2. And then we're adding that pi over 4. Right, I'm adding that pi over 4 to both sides. And get a common denominator. So multiply this by 2, top and bottom, to get the common denominator of 4. Those are the only ones that are like terms, right? Because this has an x in it. So it will be y equals my slope, pi plus 1 over 2. If you want to put parentheses there, you can. X minus, what is that? 2 pi plus 2 over 4 plus pi over 4. I put this in parentheses because this has a minus out front. So I want to make sure that I don't just say, oh, 2 pi plus pi is 3 pi, because this has a minus. So it's really minus 2 pi minus 2. And then you're adding that pi. So minus 2 pi plus pi is really just negative 1 pi. So it'll be minus pi over 4, right? This 2 pi over 4, negative 2 pi over 4 plus pi over 4 becomes minus pi over 4, and then minus 2 over 4. This 2 over 4, which is 1/2. So not a pretty answer, but that's one way you can simplify it to put it in y equals mx plus b. Again, on a quiz or a test, you can just leave it in the point slope form. You already did the hard work in finding the slope. Let's try another example involving our inverse trig functions with product rules and quotient rules. Let's try this example, which I guess it doesn't involve a quotient rule or a product rule, but it involves a chain rule. So find the derivative of f of x equals secant inverse of x plus 3. So I don't have just x in here. So here I'm going to need to use chain rule. And it's secant inverse, so let's see. What do I know? We know that when y equals secant inverse of x, then the derivative is 1 over x times the square root of x squared minus 1. And so with the chain rule, what will that look like? That means that if y equals secant inverse of f of x, right, some function, secant inverse of stuff, then the derivative is 1 over the stuff, 1 over f of x, times the square root of the stuff square. And then by the chain rule times the derivative of the stuff. So this is the chain rule part. And also that we're leaving the inside alone. So when I have f of x equals secant inverse of stuff, right? It's not just x. That's how I know that I have to use the chain rule. Then f prime of x will be 1 over the f of x, so 1 over x plus 3 times the square root of the f of x squared, so x plus 3, the stuff square, minus 1, and then times the derivative of the inside, which in this case, it is nice that the derivative of that is just 1. So our final answer will be 1 over x plus 3, the square root of x plus 3 square minus 1. Don't worry about multiplying that out. You can just leave it like that. Now, had this been like secant inverse of x squared plus 3, right? And then I will have x squared plus 3 there, x squared plus 3 square there, and then this will be the derivative of x squared plus 3. So this, the derivative of x squared, will be then 2x. So I will have a 2x on the top. All right. And my last example, I'm actually going to have you do it on your own and then email me if you have any questions or if you want to see the answer, but I want you to try it on your own. So notice that in this case, we're going to have, you have a division of functions, so we're going to use the quotient rule to start off. But also notice that you have not just x in there, so you're also going to need the chain rule there. So those are the two things that you need for this problem. Try it on your own. Email me for the solution.